Hello and welcome back to Calculus 1 Exam 2 review. So, in your infinite wisdom, right? You pick to have exam and quizzes and all of these kind of things. So let's talk about it. Exam 2 is on chapter 3, unless you want to put more stuff on it. Any ideas? No? It's fine? Okay. 11 sections, right? So, chapter 3. Now, we can summarize the entire chapter into like 3 things. If you want me to put the entire chapter into 3 things, I'm just going to say way to take the derivative, tangent line, and 3.11 related rates. There you go. Review over. What do you have under way to take the derivative? Limit definition from 3.1. I'm going to list all of this, but let's just go verbally through it. 3.1 limit definition, the long, painful one. 3.2 basic rules, right? And then you have product, quotient, chain, implicit, logarithmic, exponential, trigonometric, inverse trigonometric, right? So all of that stuff stuffed in the first line. Just here's a function, take the derivative of it, right? The second line utilizes the first line to find the derivative to get the slope. And the third one, related rates, which utilizes implicit differentiation. See? So, 3 problems would do. Right? The entire exam, you do 3 problems. Problem number 1, give you some terrible thing, and you just do logarithmic differentiation in one line. Great. There's your 33.33% of the grade. And then the tangent line, you do another derivative, and then word problem at the end, and yay, exam over, right? Except we're going to have about 10 problems. Some of them will have A and B. So especially those, cheap ones. You are going to have one limit problem, which is calculating the derivative of the function long way, utilizing the f of x plus h minus f of x, right? It's going to be one of those. And then, 2 or 3 from basic, and then you have the product rule, quotient rule, chain rule, so all of those things. So, limit definition, which is limit h goes to 0, f of x plus h minus f of x. Generally, students like to review this one. By the way, next week, SI session before the class, 7:30, right? No? Should I cancel? Because she asked me last night. So it's on? Okay, just checking. So 7:30. So limit definition, basic derivatives, product, quotient, chain rule, implicit, by the way, in basic I'm going to stuff the trigonometric as well, because learning the derivative of sine is cosine, that's the basic idea. It's not right, so I'll add trig there, an inverse trig. So all of those are like basic stuff. So implicit differentiation, and we have one more, logarithmic differentiation, and then we have 3 related rates, word problems. Now, sense the tone, tangent line. So whatever method you have to employ to get the derivative and then compute it and do so. All right, so now what's in the basic derivatives? So that breaks down into 1, 2, 3, 4, right? So you have the derivative of a constant is 0. The derivative of x to the n is nx to the n minus 1. Go through ease and everything else into trig. The inverse trig, make sure you know inverse sine and inverse tangent. Those are the most frequent ones, right? I mean, the rest is, you know, if you want to better yourself and so on, you know. Trig, so inverse. So you need to know all 6 trig derivatives. So, right, and for the inverses, inverse sine, inverse tangent are very, very frequent. That's the exam. You want to add anything? We have continuity, asymptotes. Maybe we should include asymptotes. Did you guys do well on that one? Because if you haven't done well, there will be a good thing to review. I'll take a look at my records and see how well you did on asymptotes. Okay? If you didn't do well on asymptotes, I'll put another problem on asymptotes. No, the limit, to use the limit to find the asymptote. That's always a good question. You can't find asymptote, you know, some stuff that you build might explode. You just ask Samsung. Right? So.
Oh, Samsung.
There we go. It's the noodle company. With a clothing line and tanks. See, people see Samsung, they see a TV and a phone. They started as a noodle company. You know what noodles are? You eat those things in the water, right? Yeah. That's where they started. And they're one of the biggest contractors in the world that make tanks. You know, the war tanks? Yeah. Not the video game, I mean the real ones. They build everything. They have a clothing line. Do you have a coat made by Samsung? It exists somewhere. So yeah. It's a whole new level of wearables. You have a phone to match the watch to match your coat. It's one of the giants companies. So they build everything. All right, good. So now that we reviewed Samsung, let's see what else. A limit procedure for the derivative. We have to have that, right? That's the definition. If I put the question which says write the product rule formula, write the quotient rule formula, chain rule formula. So if I put the question like that, honestly, I do expect thank you notes. All right, because that's free grade. You don't know product rule formula, like why show up? Technically. So that's that. And show all work, obviously. If the answer that you have is wrong and there's no work, there's no partial credit, that should be common sense. I think that's it. Any questions, concerns? Maybe we should just limit the question. Any problems that you would like to address, work out? Quizzes start tomorrow, by the way. Any problems that you would like me to solve? Yes. What does it say?
It's 4 sine of x cosine of x, where x equals 5.
4 sine x cosine x.
Where x equals 5.
But what are we supposed to do? Tangent line?
Find this way.
Okay. So sounds like a tangent line problem. Great, thank you. All right. At pi over 2? I'm not happy with the cosine and pi over 2 because it gives you 0. That's fine. Let's do it. No, that's actually everything's fine. All right. All right. So we have this now. I have to start bringing my sunglasses with me because now there's a boss move that I can do. I don't have glasses to match it. To find the derivative, what do we use? The answer is yes, but let's not. We use the trig identity, right? I copy this into 2 sine of 2x because there's a trig identity that says that 2 sine cosine is sine 2x, and since you had 4, so 1 2 is used up in the formula and the other 2 is rare. And all of a sudden, where's your product rule? Exactly, right? So product rule is gone, which is one of the cool things. So what did I use? From your trig course, I used the fact that sine 2x is equal to 2 sine x cosine x, which is the formula that exists there. Now, you know what? Go ahead, do the product rule. You're going to get the same stuff, except obviously it's much more work. All right, so what's my derivative over here? What's my dy dx? Well, dy dx is copy the constant. The derivative of sine is cosine 2x, and then times the derivative of the inside, which is there, the chain rule. So now the derivative is 4 cosine 2x. What do we know? If you compute the derivative, compute the point in the derivative, you get the slope. So slope is the derivative computed at pi over 2. So that's the notation to say compute the derivative. You put a vertical line and you say x equals pi over 2. That means compute at pi over 2. So that's 4 cosine 2 times pi over 2. These guys cancel. Cosine of pi is? Cosine of pi is? Very good. So that's negative 4. So we have the slope is negative 4. Actually, so now we plug in into original equation. We plug in pi over 2. We get sine 2 times pi over 2, which is very good. So the answer is 0. So what do I have as specs to find the tangent line? Easy. I have that slope is equal to negative 4, and the point is pi over 2, 0. Great. Y equal mx plus b. Y is 0, m is negative 4, x is pi over 2, plus b, from where b is clearly 2 pi. Right? 4 and 2 cancels. So you have negative 2 pi, ship it to the other side of the equation, becomes positive 2 pi. So what's the slope? What's the tangent line? It's y equals negative 4x plus 2 pi. Tangent line. Line. Happy? Anyone else with any problem? Yes? Beautiful. Tangent inverse of? Now plus 1 is included like that?
Yep.
Excellent. Right. tangent inverse. Before we do this, I want to remind you of building up these formulas from the vanilla state to ones when you have a function, right? Using the chain rule. So the derivative of inverse tangent of just x, right, was 1 over 1 plus x squared. So this is the one that you absolutely must memorize and know. But now we're going to go a step further and have tangent inverse of f of x, which is a function. And in that case, you have f prime of x on top, right, in the numerator, and 1 plus f squared in denominator. So you should be able to do this now. What's y prime equal to? 21x
over 1 plus.
No, 21x squared. So 21x squared. That's when you follow in the formulas, make sure that you understand that stuff in the red is the f of x, right? Not the whole thing is f of x. It's just the argument of inverse tangent is f of x. So you see when f of x matches here for the tangent, that's the derivative and that's the original f of x. All arguments of inverse tan. Divided by what? 1 plus?
Is it just the 7x plus 3, 10x 3 plus 1, sorry.
Yes. So, what do? This is cut and paste and square it, and then it's derivative on top. Good. Any other questions, concerns? Yes?
For your test or chain rule, do you care what version you use?
No. Chain rule is chain rule. It's been largely unchanged since it was developed in the 1700s. So. Just get that 7. I'm sorry? The last. Zoom in. Oh, you want to see this? Why don't you say so? Any other problems? Anyone? Apparently everyone is good. If I need extra problems, add. Generally, I have enough. It's your official request, I guess. Can I augment the list? No questions? Oh.
One of the things was HR equals 6 minus 5R minus square root of R over...
HR equals...
6 minus 5R minus square root of R over R plus 5.
So now, is this like H times R over here?
No, that was like a function.
Oh, H of R.
Yeah, H bar. And then you have to find the derivative.
In terms of R. All right. Let's do the derivative. Well, for stuff like this, the quotient rule works the fastest. We're looking for dH or dr. And we use the quotient rule. I have R plus 5 squared, and then I have R plus 5 over here. And then the derivative of the top. Well, that's going to be derivative of 6 is 0. So we have the derivative of negative 5R is negative 5 minus 1 over 2 root R in denominator. You might want to memorize that derivative of square root of x is 1 over 2 root x to, get these derivatives faster. We copy the numerator and then derivative of the denominator is just 1. So now we have some FOILing to do to simplify all of this. So when we FOIL, we get negative 5R minus R over this. So this is just the square root of R when you... So minus 1/2 root R minus 25 and then minus 1 over... No, 5 over, right, we're multiplying now this, it's 5 over 2 root R. So that's the first term, and the second term is just simply minus 6 plus 5R minus root R, everything R plus 5 squared. So now, combine like terms. And I have like terms. So, let's start with the R's. These guys cancel. Negative 1/2 and negative root R are going to give me negative 3/2 root R. And then I have minus 31, thank you, and minus 5 over 2 root R divided by, we have R plus 5 squared. So what I'm going to do is I'm going to multiply by root R, numerator and denominator, and when I multiply it through, root R times root R is just R, so negative 3/2. I'm also going to multiply 2, so I don't have any fractions. So this becomes negative 3R because 2 and 2 cancel, and then you have root R times root R is R, so there you go, negative 3R, minus 62 root R, and on the second parenthesis everything cancels, so it's just minus 5. The denominator cancels is 2 root r, so 2 root r and 2 root r, they cancel. And in the denominator, you just put this in front. So 2 root r plus 5 squared. Now some of you will say, well, no square roots in the denominator. No square root of 5 in the denominator. Square root of r, it's fine in the denominator because r could be 4, could be 36, right? You can take the square root like this for those numbers. Sure, it could be 7. But if it is 7, then you go and do extra work, right? We don't do extra work if we don't have to. So that's the answer for the derivative. We use the quotient rule to solve this derivative. Can we use logarithmic differentiation? Yeah, we can. But as I said, if you're putting up a picture on the wall, you don't really use the sledgehammer. You can, but you don't. Cool? Anything else that you might be interested in?
We need to get like a list of things that I've memorized.
I did. Right here.
Oh, yeah.
Right? Well, product rule and the quotient rule formulas. Oh, please, come on, keyboard. Like product rule and the quotient rule formulas, the chain rule, right? Implicit differentiation and logarithmic differentiation are processes, right? They don't have formulas. So product rule has a formula. And then basic ones have formulas. You have to memorize the formula for x to the n, right? Obviously, x squared, 2x, right? X cubed, 3x squared. But it's that formula, that n, x to the n minus 1, that gives you that. The derivative of square root of x, the derivative of 1 over x to the 10th, and so on. So that's all of those are done with that. 6 trig formulas, 2 inverse trig, right? Inverse sine and inverse tangent, where inverse tangent is the most important. And then what else for memorizing? The rest are procedures, right? You have a procedure, related rates, that's going to be, we've seen it today. Related rates is chain rule, implicit differentiation, actually, which is chain. That's all that. Any other questions, concerns? Yes? dy dx, okay.
E to the power of negative 5x and it's cosine x.
Oh, you are supposed to find the derivative of this.
Yes.
Great. So it's just d dx, right? That's the instruction. Take the derivative. All right, so this is a wave that decays in time. You know when you have a pendulum suspended look at this. I'm not adding anything extra. What is happening? It's what? It's slowing down, right? So one more time. Look, I'm not going to move my hand. So you see how it's slowing down every time, every next repetition, it goes out less. And then eventually it stops. There we go, done, right? This is the formula for this. If you graph this on your graphing utility, you are going to get a graph in time that does that. And this over here is going to be the displacement y, in our case x. And this is the time axis. That's a space-time graph right there, because you have a dimension of time and dimension of space. So, but it's a 2D one. So, this over here explains that type of a motion. We're going to see these functions in differential equations. Now, we need to know how to differentiate this. So what do? We do the product rule, right? You have function number 1, function number 2. So we do the product rule. Copy the first times derivative of the second plus copy the second times derivative of the first. This is where the chain rule kicks in. So we copy, it's e to the right x, so copy that, and then the derivative of the exponent. So what can I factor? I can factor negative e to the negative 5x. And what's left? Sine x plus 5 cosine x is left. We want to factor again. Chapter 4 is coming up, right? Where you go equal to 0 and then solve and all these kind of things. No, I factor the minus out. So this minus and this minus go out as a factor. Great. And now you know about damped oscillating motion. I have the formula for it. You can have it with sine. I'm going to do one more thing here since it's a teachable moment. Look, if you start here and you kick it, it's sine. Because you are starting on the axis, and then it goes up, and then goes up the other way. So that's how the sine goes. Starts in the origin, it goes up, passes the line, goes down, comes back to the line. Now, what's the cosine? You start motion here. That's the cosine. It's still the same thing. Stay on the same motion. It's still going to stop and everything. How fast it stops? Governed by this. Because it's negative, it stops. If you remove this part, which is the decay part, it will not decay. It will just be waving forever. But this over here, due to gravity, air resistance, and all other things that make it stop. That's where you use in engineering to design things. Right? That's what it's for. So, you know, as soon as you are able to connect mathematics 100% to the reality that you see, first of all, it becomes relevant and interesting. Second of all, useful. You can build stuff. Before math, what do? In 20 minutes, you fire. Plus, it can't burn the house down. Salt stone doesn't burn. All right, what else? That's life before math. Anything else? It's time for the lab? Go home? No? Of course not. It's more fun here. All right then. Tangent line. Don't forget, before I stop this, I have to make sure tangent line procedure, right? You get the derivative with whatever witchcraft you have to employ, whether it's product rule or a quotient rule or whatever, and then you plug in the point to get the slope. We did one of the tangent line problems earlier, but just making sure that you guys are 100%. There is a tangent line problem 100% on the test. And the next test and the final. Otherwise, they're all garbage exams. This is your central problem, right? Central idea of measuring change. All right, great. That's it. Lab time.